Hi, this is James. Welcome to the audio mixing class, level 1, the basics. In this class, we'll be learning a lot about the different components which are part of your audio system. And we'll also see how they are integrated within the mixer and within the audio ecosystem. And we'll also look at how to best set them up and connect them and operate them so that you have the best overall results. So I'm going to start off by giving you an overview of, the lesson. And so we'll be talking about hardware, going into some audio theory, talking about some microphone techniques, mixers and mixer controls. We'll also look at connecting to and turning on the mixer. We'll do some mixing. We'll look at feedback, and then afterwards we'll look at shutting down the mixer. And so we'll be going through these bit by bit, and I'll be breaking up this video into segments as well too. So we'll do the first one on hardware, we'll pause, and then we'll make another one on audio theory afterwards. So let's begin. So the first is on hardware, and the first types of hardware are microphones. And so the different types of microphones are dynamic, and a dynamic one uses a voice coil. It's much like a conventional speaker. It's very durable, and it's also the most common type that's used for sound reinforcement. So if you imagine a diaphragm with a voice coil glued onto this, and as the diaphragm moves, it moves the voice coil, and the voice coil moves over top of a magnet. And as that metal moves over the magnet, that's what causes the electricity. So the next type of microphone is a condenser. And the condenser one uses an electrically charged capacitor. So in other words, the capacitor is two plates. One is a back plate, one is the diaphragm, which the air pushes the diaphragm. And because it is electrically charged, it needs electrical power applied to it. And so that means it needs phantom power. So you have these two plates, electricity is applied to the plates, and as the diaphragm moves, the difference between the plates is what causes the variation in voltage, and that is picked up as your audio signal. This has a better sound quality, and the reason is that if you compare it to a dynamic microphone where you have a magnet, if you have a magnet and metal and you put the two together, they kind of stick, and it takes some force to pull it apart. And so they're always kind of fighting with each other. And so that causes it to not have so much of a linear response. So it works well in the middle frequencies, but the high frequencies and low frequencies tend to have a little bit of change in them. Whereas when you have a condenser microphone, it's actually consistent from bass to mid to treble. So you end up having better highs and better lows using condenser mics. That being said, there are other differences between the microphones, such as a dynamic mic generally can take more volume, more sound pressure into the microphone without distortion, whereas a condenser microphone oftentimes does not have enough capability to take high levels and might distort. And so you might have reasons why you want to use a dynamic microphone versus a condenser versus a dynamic. So those are things to think about. So continuing on, also with the microphones, we have different types of pickup patterns. And these pickup patterns could be, in this particular case, omnidirectional, which picks up sound from all directions. But there's also unidirectional. And that means that the microphone primarily picks up sound from one direction. And so if I had a microphone, which was an omnidirectional, from all directions, regardless of where I would have this microphone, it would pick up equally. But if it's a unidirectional, it would be more sensitive towards the front or the face of the microphone. So as that microphone is pointed in a particular direction, that's where it would have its most effective pickup, and sounds which would be maybe off to the side or behind it would be reduced. So that's what would be a unidirectional microphone. There are different patterns on these. Cardioid, if you see the pattern which is up towards the top, it's kind of shaped like a heart. So cardioid, like cardiac, shows you that pattern. The one below that would be more like a supercardioid or hypercardioid. And so those are a little more direct in the opening of the microphone, so it's not as wide when it picks up, so it rejects a little more sound around you, but it does have a little bit of a pickup at the back of the microphone. So it's just something to be aware of, because if you are using a speaker monitor underneath, a cardioid would obviously work better than a super or hypercardioid in that case. But if you are using a super or hyper, you might have your monitor shifted off to the side where it's on the angle as opposed to directly behind it. So those are some things to think about. So we're also going to look again on the hardware side on the unique characteristics of unidirectional microphones. Notice I say it's unique to unidirectional. It's because omnidirectional microphones don't have these features. First off is ambient sound rejection. So the sound around you, maybe there's other instruments that are playing beside you, other people that are singing beside you. Maybe it's just the overall room acoustics that you want to kind of dial out because you don't want to get all of that sound back into the microphone. Well, with that ambient sound rejection, you're basically limiting all of that excess sound from coming in, and you're only focusing on on the pickup area of the microphone. There's also what I refer to as the distance factor. Unidirectional microphones are able to effectively pick up farther than omnidirectional microphones, and that is about a 2-to-1 ratio. Whereas, an example, if you have an omnidirectional microphone and you have it at maybe 6 inches away, and this is the maximum, you set it to the maximum volume before feedback at 6 inches away. If you had a unidirectional, you could be about twice that, about 12 inches away, and have that same volume before feedback. So it's a feature because of the rejection that is within this. There's also, sorry, excuse me, there's also off-axis coloration, which is unidirectional microphones will oftentimes lose fidelity and sound muddy when it's off-axis, whereas an omnidirectional microphone will actually sound clear all the way, regardless of where you have that microphone or where you're talking into it. So if you did have a lapel microphone, as an example, that was an omnidirectional, it wouldn't matter which way that lapel microphone was pointing, it would be just as clear. Whereas if it's a microphone like this, it's clear when you're dead onto the microphone, onto the face of it, but as you start turning it away, it starts to sound less and less clear. You might still be able to turn the volume up and hear it, but it's not as clear as it would be when you're facing that microphone. And so another side of the hardware, again, unique to unidirectional microphones, is proximity effect. And this is when you have a microphone that's being used closer than 2 feet. On the frequency chart, we see that in frequencies between 50 and 1,000, we notice that there is a line, a solid line, which is lower, and then we see some dashed lines, which are indicated at 2 inches, 1 inch, and 1/8 inch, that are higher. And as you get closer, in terms of the distance, you notice that it is higher, and that higher amount represents about 4 times the volume in low frequencies. So in other words, if you're using a microphone and you're bringing it closer and closer, you actually get a boost in that bass energy. Not just a boost in volume, but a boost in volume and a boost in those bass energies. So if you notice that when people are using microphones, as they get closer to them, that it sounds boomier and boomier and boomier, that's because of the proximity effect. And then there are things that can be done in order to minimize that. So I'm going to continue on in the hardware, and we'll talk later on when we're doing some mixing and so on, to talk about how we can fix things like the bad effects of proximity effect on your microphone. We'll talk about how we can make corrections in order to help that. And so some different types of microphones that you might encounter or might see would be some maybe are head-worn, clip-on, dynamic and condenser versions of those, handheld mics, gooseneck mics, which would be the ones you might see like a podium, hanging, which might be hanging over top of a choir, boundary and pressure zone mics, which are flat mics, which could be placed on a table, an altar, maybe at the edge of a stage, maybe shotgun microphones, which are very long microphones with a lot of slots on them. and also different types of wireless mics. And as you can see, a number of them could be dynamic or even condenser. So we're going to continue on again into hardware. This time we're going to talk about connections and connectors. So there are different types of connectors. The first type is unbalanced, which is a very common type. Unbalanced connectors have two connection points, a plus and a minus, or maybe I should say the ground, as some people might say, like the plus in the ground or the signal in the ground. And these are most common for instruments. A lot of us have experienced when we've plugged in a guitar or something, or some kind of instrument, some kind of buzzing noise that takes place. And you know, this is a distinctive thing which is common with unbalanced cables and connections. In this case, to avoid the effects of it and minimize the effects of hum, your cable length should not exceed 50 feet. Oftentimes you want it less, 6 feet, 10 feet, 15 feet, that sort of thing. And stay away from these, you know, very long runs, because what happens is that you create a ground loop. And if you want to know more about that, I've already made a video how to eliminate hum on your PA system, and that talks about ground loops, what it is, and how to get rid of the hum. And so we're also now going to talk about balanced cables. And the difference with a balanced cable is now you have your plus, your minus, and your ground. Whereas before you only had like a plus and a minus, or a plus and a ground. In this particular case, you have your plus, minus, and ground. And so the signal is actually balanced over the plus and the minus in reference to ground. And that's going to reduce or eliminate your hum, and allows you to have longer cable runs for up to 1,000 feet or even more. And so that brings us to the end of the hardware section of this class. And so we're going to resume with yes, we're going to resume. No, actually, no, we're not going to resume. We're going to go back into this, because I realize we still have more hardware to talk about. And so, so let's continue on. DI boxes. And so DI boxes converts unbalanced to balanced. And that's because if you have a device such as an instrument which is unbalanced using an unbalanced cable, you want to be able to take that unbalanced signal, convert it to balanced, because you're going to need to have a cable which is longer than 50 feet if you have your instrument at the stage and your soundboard at the back of the church. And so you need to be able to have that longer length of cable, and the way to do this is use this conversion box in the middle that converts the unbalanced to balanced, so you can have it on that longer cable without the hum. It also allows instruments to connect to sound systems without, again, like without hum, and compensates levels for optimum performance. And that is because sometimes instruments just are at a different level. So maybe it's a little bit louder than you know, a microphone, but not as loud as maybe like a line connection, like a CD player. And so it helps to optimize and balance that as well too for you. Continuing on DI boxes, there are passive ones. That's what we're going to talk about. They're active as well. Passive means that it does not require any kind of power. There are no batteries internal to it. And it works with instruments, whether they're amplified or they have internal batteries, or even just if they don't need that type of thing, they work well with those types of instruments. You take the instrument, you plug in your instrument cable to it, into the DI box, and then that plugs into the mic line that goes back to the mixer. There is also a ground lift button on the DI box, and this is what helps you to remove a hum. And so the switch, the rule of thumb is, if you have an electrical item plugged in other words, you have, let's see, a keyboard, and you've plugged it into the outlet, and this is now connecting to your DI box, you will want to have the ground into the lift position. And if you are using, let's say, an acoustic guitar, and you're not using any kind of pedals, and there's no power on it except maybe an internal battery, you would want the ground in the on or ground position in order to reduce any kind of hum. So that's how you would want to do this with the DI boxes. Now, we're also going to talk briefly about wireless mics. We're not going to spend a lot of time on it, but just to kind of tell you a little bit about the differences between some of the older mic systems and some of the newer ones. And there might even be a resurgence of this type of technology in the future, and I just wanted to let you know the differences. And so there are non-diversity systems. Non-diversity, when they first came out, they didn't call them non-diversity because there was only the one, a single antenna for reception, and it required that your microphone be line of sight to the receiver. And then they came out with two antenna systems, and they called them diversity because you could have signal reception on one antenna or the other one. And because of that, it gives you a much more reliable reception. And in this case, it requires at least one antenna to be in line of sight of the microphone to give you that much greater reliability of signal reception. And so to note, there are also different types of diversity receivers. There are what's referred to as true diversity, where you have two antennas and two tuners, and the outputs of the tuners are then combined at the receiver. And this is what gives you the best quality of reception within a diversity model. There are other types, some are called space diversity and other types of diversity. The true diversity is the true and one that actually is the best quality of those. And I thought I would mention that as well too. Generally lower cost wireless microphones are not true diversity. Generally higher cost ones are. In some cases you can find a lower cost one that has true diversity, and it could be just a little bit more, a small delta more than one which is not a true diversity. And so it would be something to look into and to try and have. So continuing on in hardware, there are also items like mixers. This one is a simple sort of set and forget one, just knobs where you would have for your volumes. And this might be used to cover a small area, might be used to add a few microphones. You also have mixers such like a mixing console, which allows adjustments for each input. It may provide multiple discrete outputs. It may include advanced features as well that help the operator to, make informed adjustments. And so there are also amplifiers. Some of them are mixer amplifiers, which are kind of the simple mixer built into a small amplifier, used for places like maybe a small gathering space. It could be for public areas within the building. There are also power amplifiers as well, which would be used. And of course, different types of speakers, like in some cases, full range ones, which provide basic fidelity, maybe in hallways or in cry rooms or other areas which the room is small, but you just need to have some basic sound coverage. There could be other speakers that maybe are two-way or three-way, and these are often used for higher output or higher volume systems. There are also other types, which I'm not showing in here, maybe like line arrays, but line arrays may also comprise of two or three-way type components used in a line array type system. And of course, there are subwoofers. And it's something to note that when you have a speaker and a subwoofer, they are definitely different. And the reason that you want to have subwoofers with your speakers is because when you try and put bass energy into a speaker, the woofer within that speaker has to provide a very wide range of audio, whereas a subwoofer provides a narrow range of audio. And so air movement is really, what sound is. And when you have a woofer inside of a speaker, it may travel a certain distance back and forth to provide the bass. A subwoofer may travel a much farther distance in order to provide the bass for that type of bass energy within that frequency band. And what happens is that on a woofer speaker inside of a normal speaker, when you're trying to ask it to go beyond what it was intended to do, it actually warps the speaker as it's moving, like the speaker actually warps, and it causes what's sometimes referred to as cone distortion, where the cone starts to change shape, and therefore you start to hear differences in sound. And that can affect your low mids, it can affect your high frequencies as well too, and it can actually sound like distortion. So in other words, the speaker itself is distorting, maybe not the amplifier, maybe not the mixer, depending on how much you're doing in terms of how much output you're putting on it. So it's good to separate those signals, let the speakers do what they've been designed to do, let the subwoofers do what they were designed to do. So that was that. And now we've come to the end of the hardware, and so I'm gonna wrap it up at this point, and we'll carry on with audio theory in the next video. And so, yeah, I'll see you in the next one.